Hello everyone, in this presentation I'm going to talk about optimal planning of hybrid renewable energy system utilizing Hummer software, a case study of Ziarat Village in the Gulistan province of Iran. Renewable energy technologies are now reliable and trustworthy for electricity generation in both grid-connected and off-grid areas, reducing dependence on conventional resources. An investigation aimed at proposing an economical and optimized electricity generation design utilizing a combination of solar, wind, and biomass energy sources. The hybrid optimization model for electro-renewable Hummer software was employed to perform a techno-economic analysis and compare three scenarios. First, solar wind biomass, second, solar biomass, and finally, wind biomass, based on different urban load patterns, offering valuable insights for sustainable energy solutions in Iran. The village of Ziarat is located in the northeast of Iran. The mountains hides among dense forests. This village has more than 10,000 people, and their main sources of income are tourism and timber trade. Access roads to this area are very limited, and there is no public transportation. The development of electricity transmission network in this region is very expensive from the financial and cost, environmental and technical aspects. The government has made a lot of effort to develop hybrid resources for various purposes in this village. The main objectives of the project are as follows: design and optimize an affordable electricity generation system by propose a design that uses solar, wind, and biomass energy sources to generate electricity economically and efficiently. Analyze renewable energy scenarios by using Hummer software to compare different renewable energy combinations, such as solar, wind, biomass, or solar biomass and wind biomass, considering various urban load patterns. Promote low-carbon urban electrification by encourage the use of hybrid renewable power systems to reduce carbon emissions. To evaluate the effects of various electric load patterns on the economic and emission characteristics of hybrid electric systems, our study focuses on three main sources of renewable energy: solar energy. Photovoltaic panels harness sunlight to generate electricity, especially effective in sunny regions. It can significantly contribute to electricity demand. Wind energy. Wind turbines convert wind's kinetic energy into electricity. It complements solar power due to different patterns. Wind energy makes a sustainable grid contribution on windy days. Biomass. Biomass utilizes organic materials like agricultural residues, wood, and waste. It produces biogas, biofuels, or heat and electricity directly. And finally, battery as an energy storage device used to store electrical energy in the form of chemical energy. Choosing the appropriate renewable energy scenario depends on various factors, including the local climate, resource availability, infrastructure, and energy demand patterns. In many cases, a combination of these scenarios, along with energy storage solutions, can create a sustainable energy system for the future. Based on 100% renewable energy, three different scenarios are defined for this project. Scenario 1. By combining solar, wind, and biomass, this scenario aims to balance intermittent energy sources, solar and wind, with a more stable, controllable renewable source, biomass. It creates a diverse energy system, reducing the need for energy storage and ensuring a steady supply of electricity. Scenario 2. This scenario pairs solar energy with biomass, excluding wind as an energy source. While this scenario may lack the variability buffer provided by wind, it can still be effective in regions with ample solar resources and readily available biomass feedstock. Scenario 3. In this scenario, wind energy and biomass are combined, omitting solar energy from the mix. This scenario can be useful in regions where wind resources are abundant and consistent and where biomass feedstock is readily accessible. The table provides a comprehensive overview of power generation from different sources in three distinct hybrid energy systems, including their capital cost, operation and maintenance cost, and net present cost. In scenario 1, the electricity production relies on a combination of PV, wind, and biosources, with a 40 kilowatt per hour's battery being utilized. Moving on to scenario 2, the system employs biofuel and batteries to generate electricity, with the batteries having a large capacity of 171 kilowatt per hour. Scenario 3, on the other hand, utilizes biofuel and wind energy as the primary sources for electricity production, supported by a battery with a capacity of 268 kilowatt per hour. Analyzing the NPC, it becomes apparent that scenario 1 boosts the lowest cost among to 50.2 million US dollar. Finally, it is critical to emphasize that financial issues must be supplemented by a thorough study of energy output. Furthermore, monthly data of biomass, wind energy, and PV show dynamic interaction as well as different patterns. To subtle interactions, such as the possible reliance between biomass and wind turbines and the inverse association between bio and PV, highlight the need for more research. Rises and falls in these databases reflect complicated relationships, emphasizing the need of investigating and the mechanisms that contribute to the observed pattern. Thanks for your time and consideration.